Almost 5 billion years ago, shortly after the Sun formed, the planets of the solar system were created. Gas and micrometer-sized dust, left over from the star formation process, accumulated in a large accretion disk surrounding our newborn Sun. It is in this accretion disk that the planets, moons, asteroids, and comets of the solar system originated. As a result of forming in this disk, the orbits of the planets are nearly aligned with the Sun's equatorial plane, and all of the planets orbit the Sun in the same direction that the Sun rotates. Most of the planets, including Earth, rotate in the same counterclockwise direction as well. Since the Earth is not stationary at the center of the solar system, understanding the motions of the Sun and the planets from the Earth's point of view can be a challenging endeavor. In this digital lab, we will explore some of the less intuitive motions in the sky. Let's begin by grounding ourselves at St. Mary's College of California in Moraga, California, and stare east. Staring at the night sky at 3 a.m., the stars and planets appear fixed in place. As time progresses, we see the entire sky rotate as one, with the stars, the Sun, and the planets rising in the east and setting in the west. Over the course of one day, the sky appears fixed, with no stars or planets appearing to move relative to one another. This is a result of Earth's rotation. However, by observing the location of the Sun over the course of several days, we can see that the Sun gradually wanders relative to the constellations. Watch how the Sun's location changes as we jump forward at 8 a.m. over the course of 1 week. As you can see, relative to the constellation Gemini, the Sun appears to move towards the lower left or to the east. Over a full year, the Sun will move in this easterly direction around the entire sky. The planets also move relative to the background stars, but to observe this motion, we have to track their location over the course of several weeks or months. This is easier done at night, when the Sun is below the horizon. Turning around to face west, let's watch the location of Mars over the month of June. Comparing its nightly location to the constellation Virgo, we will see that again the planet moves in an easterly direction relative to the constellation. Here it is at the beginning of June, the second week of June, the third week of June, and at the end of June. Here we see that, relative to Virgo, Mars has moved in an easterly direction, the same direction that the Sun follows. This easterly direction is called Retrograde Motion. The Sun, and often the planets, exhibit this retrograde motion in the sky. However, we don't always see retrograde motion. Sometimes more complicated motions are observed. In this digital lab, we will explore retrograde motion in hopes of understanding how it arises and how we can predict it.